Hello everyone, in continuation with the previous video of acids and bases. Yes, I know few things are being shown up on the screen. I'll be discussing that and explaining it. We just saw what was an acid, what is a base, how do we identify a base and acid with the help of a litmus paper or a natural indicator or an olfactory indicator. And during that time I told you that we'll be discussing about the different reactions of acids and bases with different substances like metals, oxygen, carbonates, hydrogen carbonates, right? Now, when you're doing a chemical reaction, there are some gases which will be evolved or released, especially when an acid or base is involved. Okay, so there are three types of main gases which are evolved or released. It can be either hydrogen gas, oxygen gas, or carbon dioxide gas. So, how to detect whether this colorless gas which is evolved or released is a hydrogen gas, or an oxygen, or a carbon dioxide? When you bring a burning candle next to the gas which is being released, if the flame extinguishes with a pop sound, a really strong, distinct pop sound, and the flame goes off, then the gas which is released is hydrogen gas. But if the flame of the candle becomes more brightened up or it gets a little bit more increased in size, that means the gas which is released is oxygen. In a very rare cases, oxygen is released when an acid or a base is reacting. Okay. Maximum, the gas which is released is either hydrogen or carbon dioxide. If it's carbon dioxide, the flame will just simply extinguish, means goes off without any sound. Okay. If it's hydrogen, pop sound. If it's carbon dioxide, no sound. In both the cases, the flame will go off. Okay, so the first type of reaction that we are going to look into is how acids and bases react with metal. So metal reacts with an acid and it displaces or releases hydrogen. So hydrogen gas is released and a metal salt is formed. Okay, a standard method or a standard general formula for an acid reacting with metal is acid plus metal gives us salt plus hydrogen gas. We'll be looking into these reactions a little bit while. We'll be looking into how zinc reacts with hydrochloric acid, the experiment. Okay. So as you can see here in this experiment, we are taking concentrated H2SO4, okay, which is mixed with a little bit of water in a test tube. Okay. Now this is green zinc granules, means small flakes of zinc. Okay. As you can see here, these are the zinc granules, which we are actually putting into the test tube, which is having HCl and a little bit of water, right? So can you see these bubbles which are coming out? That is nothing else but hydrochloric acid, okay? So hydrogen gas fuming out during the reaction. Okay, now if I want to detect whether this gas is hydrogen, what will I do? I'll bring the candle, burning candle, and place it above the mouth of the test tube. Okay, the flame will go off or with a pop sound. So that is the indication that these bubbles which are being released is nothing but hydrogen gas. So we just saw when zinc was reacting with hydrochloric acid, we got hydrogen gas. So what is the real concept here? Hydrochloric acid, as I already mentioned, is an ionic compound which has a positive ion and a negative ion. The positive ion is the hydrogen and the negative ion is the chlorine. Zinc is also a positive ion. Zinc is highly positive compared to hydrogen. So what is zinc going to do? Zinc is going to displace, means push out the hydrogen and take the position of the hydrogen. That means it's going to react with chlorine and leave out hydrogen. So if you remember, we have already talked about displacement reaction. So zinc is going to displace hydrogen and react with chlorine. So you will get the salt, that is ZnCl, zinc chloride plus hydrogen gas. Okay, the salt that we are talking about is here is not the common salt, it's the corresponding salt. The particular metal reacting with the acid will give us the corresponding salt. Same way in the other reaction, that is magnesium reacting with hydrochloric acid, right? So here also what happens, the hydrogen is being displaced by magnesium, and we get this salt magnesium chloride plus hydrogen. Same happens with sulfuric acid with sodium. So hydrogen will be displaced by sodium and the sulfate is reacted with sodium. So you will get sodium sulfate. plus hydrogen gas, right? Again, copper with sulfuric acid, the hydrogen is displaced, so copper will react with with sulfate, sorry, and you'll get copper sulfate plus hydrogen gas, right? So any acid reacting with any metal will end up with giving you hydrogen gas and the corresponding salt. Am I clear? What happens when a particular base is reacting with a metal? Very few metals react with a base. One of the few examples is sodium hydroxide reacting with zinc. So can you see here, only the hydrogen is being displaced out as hydrogen gas and zinc combines in place of hydrogen. So you get a complex compound which is called as sodium silicate. Not all bases react with metal to form hydrogen gas. Only few do it, and only the one of the examples is I've shown it. Okay, so the first reaction that we saw, or the first active reaction of acids and base, we saw it with metals. The next is how acids react with metal carbonates. Okay, acids reacting with metal carbonate will always again form the corresponding salt, carbon dioxide and water. The general equation is acid, metal carbonate, which will give us salt, carbon dioxide plus water. Okay. So the next one we are seeing is the metal carbonate reacting with what? Sulfuric acid. Here the metal carbonate that we are taking is calcium carbonate. Okay, so as you can see here, we have taken calcium carbonate powder in a beaker, HCl, sulfuric acid in the, calcium carbonate in a small bowl, as sulfuric acid in a beaker, and a separate beaker where we'll be doing the reaction, and a matchstick to detect which gas is released. So just observe first and then I'll explain. Okay. So they're taking calcium carbonate powder in the beaker with 1 teaspoonful. Okay. Then they are adding the HCl using a nozzle. Okay. And they add it. So can you see the bubbles coming out? That means the gas is released. So how are they? We are going to detect it with a matchstick. So just observe what happens. So what happened? The matchstick stopped burning. That means, yes, the gas which is released is carbon dioxide. Sorry for the interruption. So what did we see? When calcium carbonate was reacting with HCl, the gas which was released is carbonate. Carbon dioxide. Let me just put it up here. Okay, calcium carbonate with HCl. So HCl plus calcium carbonate. What did we get? We got calcium chloride plus carbon dioxide plus water. Okay, so again, if you see HCl, if we break it off, the Cl is going to get reacted or combined with calcium. So carbonate is being split off into carbon dioxide and water. Same way, if I take HCl with sodium carbonate, the sodium is going to get hold of chlorine. The sodium and the chlorine will go together. So what is left out? Carbon dioxide and water. So I'm going to get NaCl plus carbon dioxide plus water. Am I clear? Let's take one more example. So zinc with HCl. So HCl will break off as H positive and Cl negative. Zinc carbonate will break off as zinc and carbonate. Zinc is going to react with chlorine to form zinc chloride, right? Plus, and carbon dioxide and water. So carbonate will react with hydrogen to give carbon dioxide and water. So what is the general equation? Acid plus metal carbonate is going to give you salt plus carbon dioxide plus water. The same thing will happen when you're reacting an acid with metal hydrogen carbonate. Okay, what is a hydrogen carbonate? When any metal carbonate is mixed with water, you get metal hydrogen carbonate. So when metal hydrogen carbonate is reacted with acid. Okay, so again you're getting salt, carbon dioxide and water. First, let's understand this reaction and then we'll go into the experiment. So here sodium hydrogen carbonate is react with HCl. Now HCO3 is the negative part, means the anion, and sodium is the positive part. So we'll split the ionic compound as negative and positive. Same way HCl, we are splitting it as H to be the positive and Cl to be the negative. So Na is going to react, means sodium is going to react with chlorine. So that will give me NaCl. Okay, that is a double displacement kind of a situation. Now I have hydrogen carbonate left out, which will react with hydrogen. So it will give me again carbon dioxide and water. Correct? Next, magnesium hydrogen carbonate reacting with hydrochloric acid. The positive ion or the cation is magnesium, negative ion is hydrogen carbonate. Correct? Here in HCl, chlorine is the negative ion and hydrogen is the positive ion. So magnesium is going to displace the hydrogen. So you get magnesium chloride. Right? Plus CO2 plus H2O. Am I clear? Right? So let's look into the experiment of reacting hydrochloric acid with sodium hydrogen carbonate. So here they are taking HCl on the left side beaker and sodium hydrogen carbonate on the right side. They are pouring the acid inside the sodium hydrogen carbonate. Can you see the bubbles fizzling out? It's carbon dioxide which is released. Okay, can you see it? And the liquid part is sodium. Okay. So as in the reaction, the bubbles were carbon dioxide. There was a liquid part with, sorry, I mentioned that sodium, but it is nothing but the water. And there is a sodium chloride, which is your salt, which we cannot see because it's dissolved in the water. Again, a quick review in the equation, in the experiment. Sodium hydrogen chloride mixed into sodium hydrogen carbonate. Bubbles are fizzling out, right? A little bit later, carbon dioxide is completely released. So what is left out is salt in the bottom and water, right? So the carbon dioxide gas which is evolved is passed through the lime water, then it forms calcium carbonate. So calcium hydroxide plus carbon dioxide gives us calcium carbonate plus water. So the carbon dioxide that we got in the previous reactions, that is when metal reacting with hydrogen carbonate or metal reacting with carbonate. Sorry, metal carbonate, so metal hydrogen carbonate is reacting with an acid. So the carbon dioxide that we got, that carbon dioxide is allowed to pass through lime water and we get calcium carbonate. Calcium hydroxide reacted with the carbon dioxide gives us calcium carbonate. Correct? Limestone, chalk, marble, they all are calcium carbonate. So what is the final thing? When any acid is reacting with metal hydrogen carbonate or metal carbonate, the end product is salt, carbon dioxide and water. Correct? Next, what happens when the reaction of a metal oxide with acid? What is a metal oxide? Metal oxide is when any metal is reacted with oxygen, the compound that you get is called as metal oxide. So when an acid is reacted with the metal oxide, it gives us salt plus water. Okay, so let's have a quick look into the reaction experiment and then we'll come back to this. So here we are taking copper oxide, okay, in the test tube and we are going to add, and the person is adding hydrochloric acid inside the test tube which is already having copper oxide. So cupric oxide reacting with HCl. Can you see the change in color? Right? Why? Because cuprous chloride or copper chloride is formed. Right? So copper with one which was insoluble form in copper oxide has reacted with hydrochloric acid to form a soluble salt which is a copper chloride. Okay. So copper oxide was an insoluble substance. When we reacted with HCl, we got copper chloride plus water. So here you can see how copper has displaced hydrogen. So copper has reacted with the chlorine and hydrogen was left out which reacts with water. So hydrogen is displaced. Okay. And we get copper chloride and water. So same way if I talk about magnesium chloride reacting with HCl. So magnesium is going to displace hydrogen. So you will get magnesium chloride, plus what? Yes, water. Okay. Same way potassium oxide reacting with hydrochloric acid. So potassium is going to displace hydrogen. So you'll get potassium chloride plus water. So again, any metal oxide reacting with acid will give us a salt, corresponding salt and water. Okay. The next is a non-metal oxide reacting with base. The only non-metal oxide which react with a base is a calcium hydroxide react with carbon dioxide. Carbon dioxide is a non-metal oxide and calcium hydroxide is a base. You will get calcium carbonate plus water. Hope these reactions are clear. Thank you.